Okay, this is 1.2 and 1.3 from November 2017, grade 10, paper 1. 1.2.1, the directions say factorize, and it's very important to read the directions carefully because if the word said simplify, that would be a different task. So our goal in factorizing is to create parentheses and create factors of this expression. So the first thing I notice is that we have r minus s and negative r plus s. These are opposites of each other, just like 2 and negative 2 are opposites of each other. So if I factor out a negative 1 from the second expression, I can get negative 1 times r minus s, and then I do have a common factor that I can factor out. My common factor is r minus s. So I can factor that out, and I'm left with t squared minus 1. You may notice I've used the word factor instead of factorize. That's a difference in American language for this. Now, t squared minus 1 reminds me of a difference of squares, and that is a special kind of factoring that you may have learned. A squared minus b squared can be factored into a minus b times a plus b. You can check that by multiplying it out, but this is worth learning and recognizing. So in this case, we would have t equal to a and 1 equal to b. And so we can factorize t squared minus 1 into t minus 1 and t plus 1. And that is fully factored. Now 1.2.2 has an expression in the numerator that is also a special kind of factoring problem, and that is a sum of cubes. That is a cubed plus b cubed, and that can be factored into a plus b, a squared minus ab plus b squared. And you can check that by multiplying it through carefully. And a difference of squares is also something that can be factored. And these are formulas that I think are worth learning. So in this case, x cubed plus 3, the a is equal to x and the b is equal to 1. So that numerator can be factored into x plus 1, x squared minus 1x plus 1. And we still have our denominator. And we might notice that the numerator and denominator share a factor, so we can reduce that. And our final answer is x plus 1. Okay, let's move on to 1.3. 1.3.1. These say simplify, which I think of as the opposite of factoring. We are actually multiplying this out. And if we have two terms, binomial by 3 terms, we are going to do 6 multiplications. And we just want to keep track of that. So we can think of it as 2y times the 3 terms of the trinomial, and then the 3 times the 3 terms of the trinomial. So just keep close track. We get 14y cubed minus 12y squared minus 16y plus 21y squared minus 18y minus 24. And then we combine like terms to further simplify. And our like terms here are the y squared terms. And we also have the y terms that we can combine. So we add those together, so we keep our 14y cubed, We add negative 12y squared and positive 21y squared, and we get plus 9y squared. And then our negative 16y and our negative 18y, negative 34y, and minus 24. And that is fully simplified, no parentheses. Okay, 1.3.2 is combining two rational expressions, and we need to find a common denominator. And I like to rewrite with the first denominator factored and with the second denominator written out as two factors. So I haven't really changed anything here. I've just written it out so I can see what we need. Now our common denominator here has to be something that we can build from both of these expressions. And I see that our common denominator will be x minus 3 times x minus 3 times x plus 3. And what we do to build that is we multiply each of our expressions by 1, but we multiply it by 1 in a certain form that will be helpful in getting that common denominator. So in this first term, I'm multiplying by 1, x minus 3 over x minus 3. And in the second expression, I'll multiply by 1 in the form of x plus 3 over x plus 3. And then we have the same denominator and we can combine the fractions. So then we get 3 times x minus 3 plus 2 times x plus 3 in our numerator all over our denominator. And we can further simplify the numerator by distributing and combining like terms. And we can rewrite our denominator in simplified form if we'd like to, although it's not changing anything, it's just a rewrite. And we get 5x minus 3 in the numerator and x minus 3 squared times x plus 3 as our final answer. Okay, and finally we have 1.3.3. This is interesting because the directions say simplify, but in order to do that, we really have to rewrite this and see that we can factor out something. So I am going to rewrite in my numerator this second term as 3 to the t times 3 to the negative 2. And that comes from an exponent property that looks like this. And I am just reversing that, so I'm splitting up and writing it with the base twice, and then I put my exponents up there. And in the denominator, I have 2 times 3 to the t minus 3 to the t. Now you might notice that all of our terms here have 3 to the t as a part of them. So in the numerator, I could factor out 3 to the t, and I'm left with 1 minus 3 to the negative 2. And in the denominator, I could factor out a 3 to the t, and I'm left with 2 minus 1. Interesting, because those 3 to the t's can be reduced, canceled. That just equals 1. And I'm left with 1 minus 3 to the negative 2 over 1. Which just equals 1 minus 3 to the negative 2. Now to further simplify that, we use a rule, negative exponent rule, that allows us to rewrite that 3 to the negative 2 is 1 over 3 squared, which is 1/9, and 9/9 minus 1/9 is equal to 8/9. And that is fully simplified.